Well, today is I'm going to be finishing some more variable separables, showing you some situations that we haven't done. Then we'll move on to start our last section. And our last section is solving linear differential equations. And that's pretty much us done. Oh, so pretty ugly one. First thing we need to do is to rearrange it by separating the variables. And by that I mean I want t's on the top and I want thetas on the bottom. So if I just cover up those guys, can you see right now the t to the 7's on the top, but that e t to the power of 8 is in the wrong place. It's on the bottom. So what will happen when you take this guy who's on the bottom and I rewrite it on the top? How will I rewrite it to make that algebraically equivalent? What happens when this guy goes from here and I move it up to here? What do you do algebraically to it?
It would be e to the negative t to the 8th.
Agreed. You all comfortable with that? Now let's look at the theta. Theta's on the bottom, that's good. Be careful about this one. That secant theta is going to come downstairs. What does secant theta become when you bring it downstairs?
Could you just convert it into a cosine theta?
It does. Isn't secant already 1 over cosine? So when you bring it downstairs, it kind of rewrites itself and becomes cosine. I wouldn't call that secant theta to the power of -1. If you did that, wouldn't it just make it ridiculous when you had to integrate? It just wouldn't make sense. Now, variables are separable. We can now do theta, cosine theta, d theta, and in the other direction, we're going to do this guy. And I'm going to do these separately. So let's figure out this fellow one. What technique will I use to integrate theta cosine theta? What method will I use to integrate theta cosine theta?
Would it be integration by parts?
It would indeed. And this will be the f, and this guy here will be the g. So it's going to be f of theta, capital G of theta, take away the integral of f dash theta, capital G of theta, d theta. Do you see, you have to be able to recognize the technique that you're going to use to integrate. Otherwise, that question's dead, isn't it? Well, I don't know how to integrate it, so I guess I'm finished. You know, I can't solve it. So, leave this guy alone. If you integrate a cosine, you get a positive sign. Differentiate this guy, you get 1. Integrate that, and you get a positive sign. So we now have theta sine theta, take away the integral of sine theta d theta. But that I can integrate, it's negative cosine. So 2 negatives make a positive. So theta sine theta, positive cosine theta, and we're done. So this guy here is going to be theta sine theta plus cosine theta. Now, let's look at this fella. What technique am I going to use to integrate this ugly thing?
U sub.
Agreed. What U sub do you want?
Negative t to the 8th.
Oh, okay. Not the one I choose, but that doesn't make it wrong. It just makes it different. So when you differentiate with respect to t, you get -8 t to the 7. You do the crossover. And then divide both sides to isolate the dt. So this becomes t to the 7 e to the u -1/8 t to the 7's du's. They cancel, and you get -1/8 e to the u. And that is pretty easy to integrate. And then you replace it back to the t's. So this fella is -1/8 e to the negative t to the 8 plus c. Now, normally we would have a situation where the guy on the left was e to the t or sine theta, or it would be something that we could solve in terms of this variable. In this case, can you see that that isn't going to happen? Would you agree there's no way in the world this is going to be any good? So in a kind of nice sort of a way, there is the answer. Now, there are a couple of things people have told me in another class that might be causing problems with WebAssign. First one is use a capital C, not a little c. Second one, don't use the E on the keyboard. Right, don't just hit the button E. In the menu, there is an E to the thingy bob going on. You can actually use that button. Now, I don't know which one of those two fixed his problem, but he was writing down the correct answer, but it wasn't accepting it. So I told him to make that a plus C, and I told him to use that. He did both, and it accepted it. So you might find that you only need to make sure the capital C works and everything's cool. You might have to make sure that you use the key in the math palette, right, that does the E to the power, rather than just the E on the keyboard, because maybe that's the issue. I guess it could be that both things have to be done. You'll figure that out when you do it. It's really just WebAssign being WebAssign. Are we good with this question? The fact that you can't really solve it any more than it already is, so you leave it alone. Okay. Next fella. Let's do version 8. We have our classic. This is a little different. I believe this is the first time we ever got a boundary condition. What this guy's job is, he will allow us to find out what number C is. That is going to come later. I want this to be separated. I want X's on the top. I want Y's on the bottom. I'm quite happy about the 9X, so I'll leave that. What will happen to E to the Y when I bring it downstairs? What will it turn into?
E to the negative Y.
Right. Are we getting a little bit more comfortable once you've seen it happen a couple of times? You know, that's what you do. Now, in this format, we can then do the crossover. This guy is pretty easy to do. That's his integral. This guy is a power rule. And we're looking like that. Agreed? This question can be written eventually as y equals. Can you see that the left-hand side is relatively simple, right? There's only one place where there's a y. When you see that, you know you can turn it into a y equals, and you're expected to do that. I tend to do these things very slowly because I screw up if I do too much at once. If you multiply both sides by -1, you get that. Are you happy about the plus c still being plus c? I'm just up there as well. Okay, tell me where to go next. What could I do to both sides to get closer to having y on its own?
Do the natural log of both sides.
And if you take natural log of both sides, you have this guy. And how about just multiplying everybody by -1? Now, that would normally be us finished. That guy there, right, would normally be the end of the question. When it's got a plus c in it, we call this the general solution to the differential equation. But we've got new information. We know this fellow, it's called the boundary condition. What this is saying is that when x equals 0, y equals 0. And so I'm going to use that here. Y is 0 when x is 0. So 0 is the negative natural log of c. It's, you know, negative 9/2 times nothing squares down nothing. Right, now, with a bit of luck, you should be able to tell me what number c is. I think you said it in your lips were moving. What was that number?
1.
It's 1. You'll agree that natural log of 1 is 0. And that means we can now write down the solution in a much more specific way. It's no longer negative 9/2 x squared plus any c you like. It's now plus 1. And when you know everything, if there's no plus c's involved, we call this guy the particular solution to the differential equation. Are we happy about the extra step now where we'll find the c? Right. We're going to move this one. Is it okay to move? Right. Let's see where we're off to next. Oh, there's a couple here, aren't there? Let's try 9. And the boundary condition happens to be this guy. This is not separated yet. Can someone tell me algebraically how to rewrite that that's going to make it a little bit easier to separate? A square root of pt. Another way of writing that.
8 square root p square root t.
Good start. I like it. Now, I've just called the square roots half powers. I'm going to have to do that later anyway, right? Because we're going to integrate, you need fractional powers. It's still not a fraction, but it will be in the next line. Would you agree t's go in the top, p's go in the bottom? Right. So there is the t's. What's going to happen to this half power, p to the half, when it comes downstairs?
P to the -1/2.
Would you agree it's now separated into the top and the bottom the way it needs to be? So the crossover that's a half, by the way, is that add 1 to the power and divide by the new power. Add 1 to the power and divide by the new power. Well, divide by 3/2 is the same as 2/3. That's why that's 16/3. Now, I certainly don't like the way this is written, so I'm going to turn that into this fella, and I'm going to turn that guy there into that guy. Now, the left-hand side is simple enough that we should be able to turn it into P equals eventually. Let's just do it slowly. What could you do to both sides to get it closer to being P on its own?
Divide by 2.
And divide that by 2 and you get 8/3. And you divide that guy by 2, you get plus C. Right, it's the funny algebra of C's. What do you do to both sides to finish? What do you do to both sides to get P?
Square both sides.
Right, so put a big bracket around it in a square. So what we've got is our, what we call the general solution, right? And in lots of questions, that would be us finished, but not today. You see, you've got the boundary condition. And what does that tell me? It tells me that when t is equal to 1, the p is equal to 7. So p is equal to 8/3 this guy plus c squared. That's 7. 8/3, well, basically that's 1. Now I have to figure out how to get the exact value of C. Right now, that's what we've got. What should I do next? To both sides.
Take the square root of both sides.
Right, and I'll assume that it's positive. And then can I just subtract 8/3 from both sides? It's not the prettiest answer for C, would you agree? It's a pretty ugly value, but that's what it is. So return here, and it now becomes 8/3 that guy plus C, all squared. And that is basically our solution.
Quick question.
Yes.
When we squared both sides in order to separate out the P, would that apply to the 8/3 as well?
Right. So
back when it was square root of P equals 8/3 square root
Right.
of P cubed, and then we squared both sides.
yes. Well, because I put a bracket around it and done the square, I'm saying everything inside is now being squared. So I've counted for it. I wouldn't do that guy squared plus that guy squared, because that's not how you square things. You would FOIL them out if you wanted to do it in full, which I certainly
Oh,
wouldn't.
okay.
Well, we got other questions. That was quite a good one. Looking, try to find something interesting, some different. I don't know. I know I'm going to do 12, but I've got one more to do before then. So where do I want to go? Where do I want to go? I'll do 10. So the second last one of this section is this guy. And the boundary condition is u of 0 equals -7. If you look, excuse me, that's a TA. If you look at this fraction, would you agree that it's separated? It's where it needs to be. Nothing needs to shift. T is on the top, U is on the bottom. Exactly what we wanted. So I can go straight into the crossover. Okay, integrate 2u. What do you get? Give me a nice baby question just to get you warmed up.
U squared.
Yeah. Okay, now that guy gets you t squared. What is the integral of secant squared t? That's got you thinking. Integral is secant squared. It's in the category, I have a good memory.
1 plus tan squared t.
No, what you've just done there is rewrite the identity of what it's equal to. But my question is, what's the integral of secant squared? It's not what you just said. Oh, come on, cheer me up. Somebody tell me it. Secant squared.
Tangent.
Tangent, yeah.
Yes, tangent. Is it because you haven't seen it for a while, you forgot about it? You know, isn't that the way of things? If you don't see it for a couple of weeks, you forget the answer. Okay. I don't think the next step should be difficult, but I'm going to ask it anyway. What do I do to both sides to get you?
Square root both.
Right. Now, sometimes you will hear me say, I'm assuming that it's positive. Because most of the time when I do that assumption, I'm right. I am going to assume that this is negative. Because when you take the square root of both sides, couldn't you get plus or a negative as an answer? We tend to go on the side of positive because most of the time it is. But why this time am I choosing the negative square root rather than the typical positive? There is a clue.
Because we have that -7.
You see that guy there? Yes, that's the reason. No other reason except that. So what do I know? I know that when t equals 0, that u is -7. So -7 goes there. That's why this square root has to be negative to match that negative. Nothing squared plus a tan and nothing plus c. So -7 is negative the square root of c, which means 7 is the square root of c. And won't that make c 49? So we now have our solution. It's negative the square root of this guy. And that's c, I just forgot to change it, it's 49. And that's called the particular solution to the differential equation. I hope you are getting more comfortable, familiar with solving variable separables. Right? They have a kind of flow to them. If you do enough of them, you'll get really good at them. The last question I want to do from variable separable is a version of question 12. And it says the following: find the equation of a curve that passes through the point 0.8 and whose slope, I'm assuming at that point, well, his slope is at any point is x over y. So I look at that puzzle, I'm thinking, or you might be thinking, there's not enough information to find the equation of the curve, because really isn't there an infinite number of curves in the universe? And there's a lot of them that probably pass through 0.8. So which one are you talking about, you might be asking? Well, the clue here is in that word there. Because isn't the slope the derivative? And if the slope is x over y, haven't they just told us that? Does that make sense? The slope at the point xy is x over y. The derivative is x over y. And that guy is actually ready to go. Would you agree? It's a very simple variable separable. So y dy, x dx. Power rule in both cases. And we want to solve for y, don't we? Okay, what do I do to both sides?
Multiply by 2.
Okay. And isn't 2 times c just c? We're using the funny algebra of c's. Would you agree that the next step is take the square root of both sides? And technically, I have a choice here, plus or minus. Why am I picking the positive one this time rather than the negative? Where in here is it telling me that the answer should be a positive square root and not the negative square root?
Because the point is 0.8 and the 8 is positive. which
Agreed?
is a-
Right. If that had said 0, negative 8, wouldn't I be picking the negative square root, right? So we're good to go. That's the general solution. Now, you're telling me that x is 0 and y is 8. So I'm going to put 8, 0 squared plus c. 8 is the square root of c. Would you agree that c then is 64? And since I now know what c is, y equals the square root of x squared plus 64. So there's only one curve in the universe that has the property that its slope at the point xy is x divided by its y coordinate that passes through 0, 8. Right? That's the only curve in the universe where all of that is true. It's quite remarkable how we were able to solve that puzzle with, superficially at least, not a lot of information. And that is the end of that section. Give me a few seconds to set up the next one. Our next guy is our last guy. It's going to be solving linear differential equations. Well, let's show you what a linear differential equation looks like. You know, we know what a variable separable looks like, right? dy by dx is an f of x on the top and a g of y on the bottom, right? That's what they look like. A linear differential equation looks like this. dy by dx plus some function of x, y equals some different function of x called q of x. So if you have a differential equation that has this format, first derivative on its own, plus, you know, x cubed y, that kind of thing, equals sine x, right? It has this look to it. Notice the y here, the p here, the x is on its own, right? This entire shape. If you have a differential equation that looks like that, we call it linear, and it has a solution. And its solution is a formula. It's y equals 1 over I of x, the integral of I of x, q of x, dx plus c, where I of x is e to the integral of p of x dx. And I of x has a name. It's called the integrating factor. Now, as far as formulas go, plug and chug formulas, this one isn't your typical, you know, I know all the numbers, I just plug them in and hit buttons on my calculator. Can you see this formula involves you having to find integrals of things? Do you notice that the thing called I of x is itself a very weird integral? It's e to the power of this guy. So it's helpful when you do these questions that you kind of tackle them in a very systematic way. If you kind of jump into the deep end and try and put too much in at once, you're probably going to end up, you know, screwing it up somewhere. So let's show you a very simple example of this and how I would take care of it. There's our derivative. Take away y equals 3e dx. And I'll do it in my usual kind of step 1, 2, 3, 4 kind of thing. Step 1 is make sure that the differential equation is written in its standard form. Now, very often you don't need to do step 1. Does this have the look that it needs? Do y by dx on its own? Check. Has it got a y here? Okay, you might say, well, what about the p of x? Well, can't the p of x just be 1, right? So it's okay. And would you agree it's then equal to this guy, right? So this guy is good to go. Why is that important? Can you imagine a different question where it's x times this minus 4y equals, you know, cosine x or something? You would have to divide everybody and make it look like this. Now, step 2. Identify the p of x and the q of x. Q of x is this guy. What is the value of p of x in this differential equation? What is p of x equal to? It's actually a number.
Is it 1? Negative 1?
Correct, -1. Notice that's plus p of x when you have to add -1 to get that. Now, step 3. Find the integration factor. Find e to the integral of p of x dx. E to the integral of -1 dx. Well, if you integrate -1, you get -x. The integration factor I of x doesn't get the usual typical plus c. You only need 1 plus c and it's there, right? So it's taken care of. You don't need to worry about putting it other places. Are you happy about the value of I of x and how we got it? E to the integral of p of x. Step 4. Use the formula. Now the formula says y equals 1 over the integration factor, brackets, the integral I of x, q of x, plus c. I'll do it over here because I need more room. So it's going to be 1 over e to the -x the integral of e to the negative x times q, which is that guy, dx, plus c. Okay. 1 over e to the negative x is kind of ugly way to write it. What would be a better way of writing 1 over e to the negative x?
E to the x.
Okay. Would you agree that this can be combined together to make the integration a little bit nicer, right? If you take e to the negative x and you multiply it by 3e to the x, don't the negative x and the e to the x kind of cancel each other out? Technically, you get e to the 0, which is 1, but they kind of cancel each other out. The result is that this is just 3. You see how nice that came out? And integrating 3 is 3x, I'd say. We have got our general solution to this differential equation. Are we good? Okay, now let's do just one more. It'll be a little bit longer. Again, I'm going to do is question 3, or at least one like it. And it's written down as x, y dashed plus y equals 4 square root of x. I do not like y dashed. I just don't know, my brain doesn't like it. I end up making mistakes. I much prefer this, right? So it looks more like that. Would you agree that this is not in its standard form? Shouldn't it have a dy by dx on its own, and this has an x dy by dx? You see, it's different. Right, that means we've got to fix this guy, right? What would I do to both sides to change this into what I need, which is dy by dx on its own? What would I do to both sides to get from here to here? How do you get it? Divide it by x. Now, I'm just going to write it down in a kind of clunky way right now. There, right? Now, I probably wouldn't normally write that line, but I'm just trying to emphasize I've divided everybody by x, right? I'm going to rewrite each of these pieces a little bit different. And let's see why I'm doing that. Can you see the y over x is much better if you write it as 1 over x, y? Isn't this the same as that? Can you see why I want to write it like this format to make it more obvious who p is? Can you agree it's 1 over x? Now, why am I taking this horrible mess and turning it into that even uglier looking negative half power? Why didn't I just leave it like that? Why have I done this?
Because that'll be easier to integrate later in the process.
Yeah, would you agree trying to integrate the square of x over x is probably more work than it's necessary, right? It's not the way you should leave it. Right, now, that would essentially be step 1. Right, step 2 is identify who the p of x is and who the q of x is. Okay, who is p of x in this question?
1 over x.
Would you agree that this is the other half of the puzzle? Then we move on to step 3. Step 3 is find the integration factor. So it's e to the integral of p of x. It's e to the integral of 1 over x. It's e to the natural log of x. And some of you might go, oh God, that's ridiculously ugly. Have another look. Isn't e the natural log of x actually simplifies really, really nicely? What is e to the power of the natural log of x the same thing as?
Is it
X.
just X?
It is just x. Isn't that much nicer than it was a minute ago? So now we can move on to step 4, which is use the formula. And the formula in this case is 1 over ix, brackets, the integral of I of x, q of x, dx, plus c. And we know I of x, we just found it a minute ago. So it's 1 over x. The integral of x times this fella. I'm just going to leave that 1 over x the way it is. Now, these two guys can be simplified, right? You can combine them. Wouldn't an x times an x to the negative a half end up being x to the positive a half? And so you've got 4 of them. So you've got 4x to the positive a half. Do you see the way that we wrote q down made that more obvious? If I'd left it, you know, with all those square roots that we had before, wouldn't there a good chance you wouldn't see what it became, which is actually quite nice. So we have this guy. Add 1 to the power and then divide by the new power. Excuse me. Style points tells me that. And I'm quite happy with that answer, and I hope WebAssign is. But WebAssign has at least should have a couple of versions of the same answer. This answer is basically good to go, right? I don't see any great advantage of changing it much. But can I multiply through by 1 over x? Now, if I multiply through by 1 over x, 1 over x times this guy gets you 8/3 x to the half, and 1 over x times this guy gets you 6 over x. And then I could take this guy and call it that. This is equivalent to that. You agree? Now, I guess it's a matter of taste. Do you like the look of this one more or less than the look of that one? You don't care. I'm quite happy with either of these answers. Or whatever one WebAssign wants, that's great. I'm showing you both just in case WebAssign is being a pain in the butt and it won't accept this, and you have to give me that.
Can I ask a strange question?
Yes, go for it.
So with the rules we were using before with C, where like negative C could just go to positive C, or 3C could just go to positive C, would that apply to this C over X?
No. The C has to stay as a C, but you can't call. Excuse me, I need a new lung. C over X has a variable in it, X. And because of that variable being in it, it kind of freezes it in stone. So you can't call C over X C. Now, C over 2, you can call it C. 5C, you can call it C, right? Add 1 to it, you can call it C. But everything I just mentioned there wasn't a constant. It was a number like 2 or 4 or 1. But if you do C times X, it has to be called CX. If you do C divided by X, it has to be called C over X.
Okay, perfect, thank you.
Right. Here, while we're talking about that, here, just for argument's sake, suppose I had a situation where I had 2x, 6x squared plus c, just for argument's sake. Now, I'm quite happy with that answer, but if you multiplied it out, you would have 12x cubed plus 2cx. Well, not really. Can you see that you can still tweak it a little bit? The 2c can just become a c again, right? On the other hand, if I had a 1 over 2x, I'll just make it 1 over x. If I had a 1 over x, this would become 6x, but this guy would become c over x. Do you see the difference? How certain things can, you know, in these cases, the x's can't go away, right? I guess I could do one last one. On the other hand, wouldn't this be that guy? Because this is